Okay, so we should be live streaming on YouTube, and we have a new co-host. Can you introduce yourself?
Hello, everyone. I'm ChatGPT, an AI language model developed by OpenAI. I'm here to help with coding, answer questions, and provide support for all kinds of projects. Today, we're working on enhancing a cochlear simulator web application. Feel free to ask any questions or suggest improvements as we go along.
Okay, I'm not sure if the volume is okay. Still trying to fix the setup for the microphone myself and the new co-host. So we shared some code with you already, and you were trying to help. Can you tell what's going on so far?
Sure, I'd be happy to give a quick recap of what we've been working on. We started with a basic Flask web application serving an HTML page for a cochlear implant simulator. The simulator visualizes audio input in real time and includes interactive controls for adjusting audio filters. To improve the user experience, we discussed several enhancements and decided to start with adding tooltips for better guidance and refining the UI design using native HTML, CSS, and JavaScript. We added custom tooltips to explain each control and improve the overall design with custom styles to give the simulator a more modern and polished look. Now, we're in the process of implementing these changes to make the simulator more user-friendly and visually appealing. If there are any specific
Still trying to sort out the sound and everything. Eventually, we'll have to connect you to the PC using an audio cable or a USB-C or something. Because, yeah, the sound is not great.
Got it. It sounds like you're still fine-tuning the audio setup for your live stream. It can definitely be a bit tricky to get everything working smoothly, especially with new equipment and connections. Once you have your microphone and other audio equipment set up properly, we can continue with the coding and answer any questions from the audience. If there's anything specific,
Okay, yeah, eventually I might have to edit you out from the final video, if any, coming out of this live stream. But let's get back to the Flask application development. So currently we have this thing running, okay, but we're doing some improvements. Can we focus on that?
absolutely. Let's focus on improving the Flask application. We've already made some enhancements to the UI and added tooltips for better user guidance. Let's continue with the improvements. Here are a few more steps we can take next. 1. Add audio file upload option. Allow users to upload audio files to visualize instead of using the microphone. 2. Enhance audio visualization. Add more visualization modes, such as waveforms or spectrograms. 3. Implement real-time statistics. Display real-time statistics about the audio input, like peak frequency and average amplitude. Let's start with the first improvement, adding an audio file upload option. Step 1. Add audio file upload option.
Okay, we don't want to for the user to upload files at this stage, mainly because I don't think a server would be able to handle this. I don't want any to store anyone's voice or anything like that for privacy reasons as well. Okay, again, we do not want the user to upload the voice or
Let's
anything.
focus on further.
We don't want the user to upload the voice or anything. We don't want the user to upload their voice or anything like that. Okay, we don't want the user to upload their voice for privacy reasons.
Understood. We will focus on real-time audio processing using the microphone and improving the visualization and interaction without including file uploads. Let's continue with enhancements that respect user privacy. 1. Enhance audio visualization. Add different visualization modes such as waveforms or spectrograms. 2. Implement real-time statistics. Display real-time statistics about the audio input like peak frequency and average amplitude. 3. Improve the electrode visualization. Make the electrodes more dynamic and visually informative. Step 1. Enhance audio visualization. We will add a waveform visualization along with the existing bar visualization. HTML updates. Add a toggle button for switching between visualization modes. You can see the code in our conversation history. You can see the code in our conversation history.
Like being on a phone call with this thing. Well, yeah, the main problem, well, yeah, I don't want to get into the GPT stuff. They're changing everything on a daily basis anyway, so can't keep up with that. So leave that as is. Yeah, obviously the voice is much better. That's something we definitely want to use. Before we were doing this voice.
Understood. We will focus on real-time audio processing using the microphone. Understood. We will focus on real-time audio processing using the microphone and improving the visualization and interaction without including
Thing is wrong with my audio. Yeah, as expected. Didn't think it will be doing much, but it's good to try it out. Yeah, okay, I don't wanna specifically add the extra buttons. We would like just to improve the current visualization.
Got it. We'll focus on enhancing the current visualization without adding extra buttons. Let's improve the audio visualization and make the electrodes more dynamic. Here's how we can proceed. 1. Enhance the current bar visualization. Add smooth transitions for the bar heights. Improve the color scheme for better visibility. 2. Improve the electrode visualization. Make the electrode's color transitions smoother. Add more dynamic visual feedback. Let's update the JavaScript to enhance the current visualization. Enhance JavaScript for visualization.
We also do not have a CSS for this particular project. We have a CSS for the whole website, but not individual projects. So if there's any specific styling within the project, we need to handle it using JavaScript or HTML.
Understood. We will manage the styling directly within the HTML and JavaScript for this project.
Yeah, so this chat, it's still doing something. Hey, can you also let's try generating prompts for GitHub Copilot to do the actual coding. Let's try generating prompts for GitHub Copilot to do the actual coding. Can you do that? It's still thinking about something. I think it really doesn't like me viewing the chat on the PC. But it is doing what I ask for, but it's not responding in voice. Yeah, I think we so it's like calling the assistant. So it's like they're trying to assist you in text, and then you can call them as well. So it's a bit odd the way it works. But the chat, the voice is much better than what we have on the PC. So that's why I was trying to use the phone as well, the app. So it's supposedly enhanced. The code. Do we have styling at the moment? Yeah, so normally what we organizationally wise, we generate a copy every session, but then we essentially get rid of them at the next session. We select, doing like, what is it, like an A/B testing thing, and select which one actually works better, and drop the other one that we didn't like. It seemed to work fine. Kind of just, yeah, we do have some styling, but supposedly the bot improved it for us. Yeah, we have tooltips as well. I don't know if they're gonna work, because originally it wanted to add the bootstrap. It's not doing it anymore. I mean, tooltips will be nice. Would it just work without the bootstrap or any other major change to the code? We would like to keep everything local. So generally speaking, we're trying to avoid stuff in the backend as much as possible. So we're primarily focusing on HTML and JavaScript. Let's see if this HTML is much better. Set in a bunch of styling. We don't need the body because we already have it. Main container button. We have audio canvas as well. Did it just ignore it? Looks like. Yeah, it forgot the styling. Did the border rounding over there. Not sure what's that all about. Yeah, we got rid of it yesterday. We were playing around with layout toggle, where the idea was to add essentially an option to stretch this electrode array into 2D instead of a spiral like that, you know, for better visibility, for like clearer a representation of the electrode array. That's kind of common in literature. This is just kind of more realistic, but a linear array will be clearer in terms of what's what. Okay, so should we just take yeah, all that, we'll get rid of things that are not needed. Oops. Those are the 1, 2, 1, 2. Yes, we have that stuff for the whole project, for the whole Bionic Chaos project. Yeah, we did like the previous colors better. Yeah, we'll get really confused if we place the CSS for the whole project. We can give it a go. We can give it a go. That meant to be prompts. Didn't understand. Yeah, it understands if you make spelling mistakes, or if you didn't get the text to speech. I thought those tips will be over each element. Yeah, that high pass obviously by default needs to be made higher frequency. It will depend on your microphone, but generally the response should be flat like that, then it will work better. In this case, going all the way to 2 kilohertz, which is okay because you can still see lower frequencies, they're just being suppressed. So that's what happens if you have that high pass filter off, and when it's on, you just get a flatter response. Well, because you have some static or whatever noise in the very low frequencies there, so you essentially you don't filter them completely, you essentially just half them. And same for, yeah, we don't actually need the low pass, I think, for it to work properly. yeah, just originally adding the high pass would have been sufficient enough. And this probably be a good time to mention that if you haven't checked the website yet, please go do so. You'll be helping the project. And this is what we currently working on, hopefully. Yeah, the problem with me saying hopefully we'll edit soon is when I'm editing videos later. I'm currently editing live streams from 2-3 months ago. So every time I say it, that tool is actually already available on the website. So yeah, so timing can be confusing like that. Anyway, what else? Visualization electrode update, enhance the visualization directly using JavaScript. Okay, what have we done there? It's just generated the whole code, did it? The electrode is the cochlea seam. No, we also have the initialize function as the last function. So what did you do? Okay, edit, update electrode. So we have draw and it's added in our function. Why? I just split up drawing, updating electrodes in a separate function. That sounds like a good idea, but it must have done other changes as well. Yeah, and later we also asked it to generate prompts for GitHub Copilot. What's it? Create enhanced visualization. We might add them as prompts because we normally, yeah, we don't normally use prompts file, but we just add it as text. And see what we can do with it later. I mean, yeah, GitHub Copilot works very differently. So just by having those prompts there, it when using, can't actually see it, but it's behind me. Yeah, when using Copilot, if we start a new chat with the workspace handle, then in theory all the open files are taken into account, so it will take those prompts as well, maybe. This will probably not. Yeah, so it's deciding by itself which files to look at. I don't like those tooltips being just over the question mark there instead of, I was kind of expecting it to be over every item. Yeah, it's asking for more details and stuff, so that doesn't work. but updated the JavaScript for us as well. Let's actually try it out. No, it's not complete. And there's no just write cont there, see what happens. Yep, it's finishing the update electrodes function. One, two. Well, it's working fine. Yes, the styling. So again, the problem is that we have styling for the whole project. We have this styling file for the whole project. So components within this current project should be controlled from within JavaScript and HTML. These components are the ones that are not included in the style CSS for the whole website. Let's try that. Yeah, this is kind of better because it's updating the styling for within every specific item, which is better. So it didn't understand what I want. That's promising. Yes, instead of that style, I think we can get rid of it. Right, and it's brought the original colors and everything, which is good. I think those are the original colors. Okay, why is that script? This is just for the tooltip. Yeah, I suspect that's just for the tooltip, which is okay for it to be here because it's essentially part of the explanation, and the JavaScript itself didn't finish generating. So why does that didn't finish generating thing? So essentially, yeah, with the high pass filter, you just should adjust that to reduce that noise. You can say that noise when there is silence. Yeah, this bit. So this, yeah. Yeah, so 1400, that's the job. With my specific microphone. Maybe we make it 1,000 or something. Value. Yeah, let's make it that didn't work. High pass slider. It must have been overwritten in JavaScript itself. Yes, it is. Can we get rid of it considering we are setting up? Oops. Yeah, there's a lot of 20s. Min max. Yeah, this is good. This is the 1,000, I think. Yeah, the thing is changing. Okay. I don't know why you have to hit the start with microphone button every time. Can ask the bot in a sec. Our new co-host. Just have to improve its audio. Yeah, it's not updating. One, two, one, two. 1, 2, 1, 2. Okay, now it's not so bad. Okay, I stuffed something up. I stuffed something up. So the way we're working with the board is a bit peculiar. It's not ideal. We can just confirm reading the code. It doesn't generate anything else, and then we start using the bot on the phone again. Can you summarize and repeat the last response?
Sure. Here's a brief summary. HTML contains a title and introduction for the cochlear simulator. Main container includes a canvas for audio visualization, audio canvas, and a div for electrode visualization, pixel canvas. Buttons and sliders control audio filters, with tooltips explaining the controls. JavaScript creates electrodes in a spiral layout within pixel canvas, initializes audio context, and sets up low-pass and high-pass filters. Uses Web Audio API to capture audio from the microphone. Event listeners update filter values and start audio processing. Continuously updates the audio canvas and electrode colors based on frequency data. Manages tooltips for control explanations. This setup provides real-time audio visualization and interactive filter controls, with electrodes changing colors based on audio input.
Okay, how do we place audio from an Android phone into a PC, Ubuntu PC? I do have a USB-C. I can't find an audio cable. Just testing the bot, really.
To stream audio from your Android phone to your Ubuntu PC using a USB-C cable, you can use the SendCPI tool. SNDCPI is a neat utility that allows you to forward audio from your Android device to your PC using ADB, Android Debug Bridge. Here's how you can set it up. Patched step-by-step guide to set up SNDCPI 1. Install ADB on Ubuntu. Open a terminal and run the following command to install ADB. You can see the code in our conversation history. 2. Download SNDCPI. Download the SendCPI tool from its GitHub repository. SN, please open your app to see this link. Extract the downloaded zip file to a convenient location on your PC. 3. Enable USB debugging on Android. Go to Settings, About Phone on your Android device. Tap Build number 7 times to enable developer. Go back to Settings, System, Developer Options, and enable USB debugging. 4. Connect your Android phone to PC. Connect your Android phone to your Ubuntu PC using the USB-C cable. Fine. Forward audio using SNC.
Okay, I might try this later when we are not streaming. Can you give a summary of the current code? We're gonna go back to the Flask application, but can you keep it short? If you feel like being funny, go for it, but keep it on topic. This will be dangerous.
Sure. Here's a short summary of your current code. HTML contains a title and introduction for the Cochlear simulator, main container with a canvas, audio canvas, for audio visualization, and a div pixel canvas for electrode visualization. Buttons and sliders to control audio filters with tooltips for guidance. JavaScript creates electrodes in a spiral layout within pixel canvas. Initializes audio context and sets up low-pass and high-pass filters. Captures audio from the microphone using the Web Audio API. Event listeners update filter values and start audio processing. Continuously updates the audio canvas and electrode colors based on frequency data. Manages tooltips for control explanations. This setup provides real-time audio visualization with interactive filter controls, dynamically changing electrode colors based on audio input.
With the HTML and JavaScript, I made some changes, particularly to the default. I was trying to change the default value for the high pass filter, but I think I might have stuffed something up.
Got it. Let's review the HTML and JavaScript changes for the IPOS filter default value. Updated HTML. You've updated the default value for the high pass slider to 1000.
That's right. Okay. Yeah, I think it really doesn't like me.
You can see the code in our conversation history. Updated JavaScript. Adjusting the JavaScript to handle the new default value for the high pass filter. You can see the code in our conversation history.
Yeah, I can see generate a lot of code. What?
Yes, I provided the full context for both the HTML and JavaScript to ensure everything is clear. Here's a brief recap of the changes. HTML changes. Updated the default value for the high-pass filter slider, to 1000. JavaScript changes. Adjusted the JavaScript to handle the new default value for the high-pass filter, ensuring the correct initial value is set and updated dynamically. If you have any specific part you'd like to focus on or further adjust, let me know.
Okay, let's close it for a sec. Yeah, what's the plan? Yeah, we just what I was saying is that we only needed to update the default value of that. We did, but I suspect something isn't right at the moment, because when you turn it off, Yeah, something isn't right. Yes, updated to 1000. Index HTML. That shouldn't have. That should have stayed the same. This should have been the same as well. So I'm not sure why you generating why are you generating those? Should be fine. And update the JavaScript. So did you just regenerate the whole thing? Didn't finish. Yeah, I like how the copy button is at the bottom and the top. It's really nice. A summary of changes. It's not behaving as it was before. So why? One. It seemed to work. One, two. Ah, have to click the microphone. Hey, do we really need the start with microphone? Do we really need start with a microphone button, or can we get rid of it? Can it just work on loading?
Sure, we can streamline the code to focus on the essential parts without the microphone input. Let's focus on improving the visualization and electrode update log.
Okay, now it starts to annoying me. Do we absolutely must have the start with microphone button, or can the microphone get just turned on when the application starts the first time around?
You have reached the message cap for GPT-4. Please try again later.
How long is the timer?
You have reached the message cap for GPT-4. Please try again later.
Can I use a different model?
You have reached the message cap for GPT-4.
Okay, the robot is broken. It give me the error in here as well. You reached out the GPT 3.5 until limit resets in 26 minutes. I get 26-minute timer. Okay, this is how useful it is. Not very. So to answer the question, can GPT-4 not be a co-host of a YouTube channel? I think this is the answer. No. Now the question is, before it wasn't doing it, but if I hit 3.5, yeah, this one doesn't have a button. It will make sense for it to be a button to move to a different model. It's telling us to take a break, doesn't it? I was just wondering. Would this... Okay, so it's working with 3.5. Explain above code. Explain the current web application that we are developing. Yep. Let's see if it's still... Yeah, still on track. Can you continue development or... Yep. Yeah, but I don't really trust it, so... Yeah, I might wait the 20 minutes or so. I'm also paying for this. I don't know what's the limit is. I don't know why it's also not showing you. Before it actually used to have a disclaimer that, you know, there are limits. Now the disclaimer is gone. There obviously still are limits. So I don't know what's up with that. Also, if you do have limits, it would be nice to see, you know, like, you know, a bar or something filling up to the limit. And in theory, it should be a time window as well. So if you're not prompting it or anything, the limit should go down with time. Yep. Yeah, obviously some generic stuff. Clear. Yeah, if you haven't checked out biomedicals.com, please go do so. There's lots of interesting tools. The more recent one is this live simulation. So I'll just leave you with it. Take a quick break.
project and address potential issues. Prompt engineering for GitHub Copilot. Since we're not using an external CSS file, we'll focus prompts on enhancing the JavaScript, main.js, to handle the styling dynamically. Here are some strategies. 1. Clear and specific descriptions. Bad. Make electrodes spiral. Good. Position the electrode elements in a spiral pattern within the pixel canvas element. The spiral should start from the center and expand outward. Use a smooth curve and adjust the spacing to accommodate the number of electrodes. 2. Reference existing elements. Apply the rainbow gradient color scheme to the electrodes based on the band energy value. Blue should represent low energy, and red should represent high energy. Center the pixel canvas element within the main container element. 3. Request incremental improvements. Add a smooth transition effect when the electrodes change color. Make the audio bars on the audio canvas visually more appealing by adding rounded corners. Potential issues and improvements. 1. Hard-coded values. Issue. Numbers like num electrodes, max radius, or electrode dimensions are fixed within the code. Improvement. Consider making these configurable through variables or input elements in the HTML. This would allow users to customize the simulation. 2. Limited frequency bands. Issue. The number of electrodes, num electrodes, might not match the frequency resolution provided by the analyzer. Improvement. Dynamically adjust the number of frequency bands based on the analyzer's frequency bin count to ensure a more accurate representation. 3. Visual appeal. Issue. The visualization might lack visual polish. Improvement. Explore adding gradients, shadows, or other visual effects to the electrodes and audio bars to make them more visually engaging. 4. User interaction. Issue. The current interaction is limited to the start button and basic filters. Improvement. Consider adding more controls, such as a volume slider, options to change the spiral parameters, or the ability to pause and resume the visualization. 5. Accessibility. Issue. The visualization might not be accessible to users with visual impairments. Improvement. Add alternative ways to perceive the audio information, such as through vibrations or sonification. Example prompts for GitHub Copilot. Prompt 1. Create a function to dynamically calculate and set the number of frequency bands based on the analyzer. Frequency bin count. Use this calculated number to distribute the frequencies evenly across the electrodes. Prompt 2. Enhance the appearance of the audio bars on the audio canvas by adding rounded corners to each bar. Prompt 3. Introduce a subtle animation that causes the electrodes to pulse gently with a color change that corresponds to the current frequency energy. Let me know if you'd like more specific prompts or guidance on any of these improvements. Absolutely. Let's refine the code to ensure the microphone is accessed and the visualization begins immediately upon page load. Here's the improved version, along with explanations and prompts for GitHub Copilot. Explanation of changes. 1. Start visualization function. The code for initializing the audio context, requesting microphone access, and starting the visualization is now encapsulated in a function named start visualization. This makes the logic more organized and reusable. 2. Immediate invocation. The start visualization function is called immediately within the DOM content loaded event listener. This ensures that the function executes as soon as the HTML structure is loaded, initiating the microphone access and visualization without waiting for any user interaction. 3. Error handling. The try catch block is still used to handle potential errors when requesting microphone access. An alert is added within the catch block to inform the user of the error. Prompts for GitHub Copilot. Prompt 1. Encapsulate the logic to start the audio visualization, get the microphone stream, and connect the nodes into a function called start visualization. Prompt 2. Call the start visualization function as soon as the DOM content is loaded. Prompt 3. Add an alert to the catch block in the start visualization function to inform the user if there's an error accessing the microphone. Let me know if you'd like any further refinements or assistance with your project. Absolutely. This error, the audio context was not allowed to start. It must be resumed, or created, after a user gesture on the page, is a common one due to browser security restrictions. Modern browsers prevent audio from autoplaying without user interaction to avoid unexpected noise. Here's how you can adapt your code to address this, along with some guidance for GitHub Copilot. Key changes. 1. User prompt. A prompt, e.g., a clickable overlay, is added to the page, instructing the user to interact, click, to start the audio. 2. Start visualization on user action. The start visualization function is now called within the click event handler of the prompt. This ensures the audio context is created and resumed after the user gesture. 3. Prompt removal. The prompt is removed from the DOM after the user clicks it. Prompts for GitHub Copilot. Prompt 1. Add a visible prompt to the page that asks the user to click to start the audio visualization. Prompt 2. Trigger the start visualization function when the user clicks the prompt. Prompt 3. Remove the prompt from the page after the user has clicked it. Why this works? By delaying the creation and resumption of the audio context until after the user interacts with the page, you adhere to the browser's security policy and avoid the "not allowed to start" error. Let me know if you'd like any further refinements or assistance.
Okay, so I want to get rid of that button, so when we load the page, it starts working straight away. And normally it's not allowed. There's some browser policies with that, but apparently the robot says there is a way to bypass that. We are testing it at the moment. We have too many of those event listeners. We have the DOM content loaded. Was updating the stat visualization function. So commented out there. It doing that. Click to enable audio. Don't need to Control F5. Click to enable audio. Yeah, now we have like 2 clicks instead of 1. So what's the point? And something's and we got an error as well. That's not good. Yeah, so essentially we want that button to pop up. Add visible prompt to the page that asks you to quick start the audio visualization. Trigger the start visualization function, blah blah. Remove the prompt from the page. Yes, we need to do all. Hopefully we can get rid. What's the button called anyway? Can get rid of the button. Yes, essentially just need to click on the page somewhere. Just fair enough. We don't. Well, we don't have the button anymore. No, just comment it out for a sec. Okay, we got rid of the start audio button from the HTML, and we need to fix the JavaScript code because currently we're getting the following error.
Absolutely. Let's fix that error and refine the code to remove the start button and directly use the microphone upon user interaction with the prompt. Revised JavaScript, main, JS, HTML modification. Remove the start button element from your HTML, index, HTML, file. Explanation of fixes. 1. Node connection order. In the start visualization function, the connections between the audio source, filters, low-pass filter and high-pass filter, and analyzer are made after the audio context is created. This ensures that all the nodes exist before you try to connect them. 2. Error handling. The try, catch block handles potential errors during microphone access. You should replace the comment within the catch block with appropriate error handling logic, e.g., displaying an error message to the user. Additional tips. Autoplay policy. Browsers have strict autoplay policies to prevent unwanted sound. Even with user interaction, some browsers might still block autoplay if the user hasn't interacted with the page in a meaningful way, e.g., scrolling or clicking. Consider adding a brief explanation to the user that they may need to interact with the page further if the visualization doesn't start immediately. Browser compatibility. Test your code on different browsers and devices to ensure consistent behavior. The Web Audio API can have subtle differences in implementation. Let me know if you have any other questions or run into any further issues.
Yeah, this is working. 1 2 1 2. This is much better. So the bot is able to do something helpful. That's very nice. Thank you very much. The other thing is, I want to make sure, yeah, that the activation is looking fine. And just test it with turning my sound off. I'll just do annoying noises to see how the electrodes gets activated when it's more specific frequencies. Yeah, it kind of works more or less. Click to enable audio. Yep, that's working fine. What but make it user friendly instead of to click twice? No. That's already doing it. I'm not able to test. No, I was testing it. It's fine. A question. Should we add an option create a set of lectures that is evenly spaced around the center of the canvas? What? Update the color of the lecture based on the audio data. Yeah, already doing that. And that's working fine. Allow the user to adjust, update the visualization. Yep, that's working fine. The only problem is make sure how to test this. Testing with voice. Is limited. Can you click anywhere? Yeah, I would like to click on this screen. Anywhere on the page. Yes, it's two separate issues kind of thing.
Absolutely. It's great that the core functionality is working well. Here's how you can refine the electrode activation, add more robust testing options, and enhance the prompt for GitHub Copilot to guide further improvements. Refined JavaScript, main, JS. Key changes. 1. FFT size. The analyzer. FFT size is set to 2048. This controls the frequency resolution of the analysis. A higher value, e.g., 2048, provides a smoother and more detailed frequency response, which might be helpful for visualizing the electrode activation. 2. Smoothing time constant. You might also want to adjust the analyzer. Smoothing time constant if you want to control how quickly the visualization responds to changes in the audio input. Testing electrode activation more thoroughly. 1. Test tones. Use online tone generators or audio files with specific frequencies to verify that the correct electrodes are activated for each frequency range. 2. Visual inspection. While speaking or playing various sounds, visually inspect the electrodes. Observe if the colors change in a way that corresponds to the expected pitch or frequencies of the sounds. 3. Developer tools. Use the browser's developer console, usually by pressing F12, to log the frequency data and the calculated energy ratio values. This can help you debug and fine-tune the visualization. Prompts for GitHub Copilot. Prompt 1. Enhance visualization. Improve the visual appearance of the electrodes by adding a subtle glow or animation when activated. Prompt 2. Test tones. Create a feature to play test tones at specific frequencies so that the user can verify which electrodes are activated. Prompt 3. Frequency mapping. Implement a logarithmic frequency mapping for the electrodes to better represent the human auditory system's perception of pitch. Prompt 4. Volume control. Add a volume slider to the interface that allows the user to adjust the overall amplitude of the audio visualization. Let me know if you have any more questions or requests for further enhancements.
Yeah, we have to limit this band to something more reasonable. So this going up to 20 hertz, but most of the speech. One two one two. Yeah, this 1 2 1 2 1 2 1 2. And we wanted to test tones, electric intuition, develop tools, visual inspection. It's kind of working okay. Make sure the electrical bit based on the audio data. Does it mean what's called Gemini doesn't have a limit for the number of prompts and things like that? Yeah, I'd say there's a couple things that we're trying to improve with this tool before releasing it. It's all happening in JavaScript. Changing couple things at the same time. I want to make sure. Yep, that's perfect. It's working. Before we had to press on this banner, the click anywhere to enable audio. Now we can just click anywhere on the screen, which is much better. Yeah, and it won't, yeah, the browser is preventing the microphone to be used when when the page loads, unless you interact with the page. So that's working fine. So that prompt, it's working fine. And now the other thing is, yeah, so the electrode colors, I'm not sure they actually activating the correct electrode. Would be nice. Testing it with music. Shall we also test with different audio? So yeah, we can do that, but also shall the user be able to select the number of electrodes? Which will change the number of bands. That's correct. That is correct.
Absolutely. You've made some excellent observations and identified areas for improvement. Let's tackle these one by one. 1. FFT size not affecting visualization. The FFT size, fast Fourier transform, determines the frequency resolution of the analysis. A larger FFT size gives you more frequency bins, more detail in the frequency domain, while a smaller FFT size gives you fewer bins. Possible cause: the visualization might not be designed to clearly reflect changes in FFT size. Your current visualization divides the frequency bins into a fixed number of bands, based on num electrodes. If the FFT size changes, the number of bins per band changes, but the total number of bands remains the same, which might not visually show the increased frequency resolution. Solution: dynamic band allocation. Modify update electrodes to dynamically calculate the number of frequency bins per band based on the current analyzer, frequency bin count. This ensures that each electrode represents a consistent frequency range regardless of the FFT size. Visual feedback. Consider adding a visual element to the UI, e.g., a text display, that shows the current FFT size and the number of bins per band. This can help users understand how changing the FFT size affects the visualization. 2. Electrode angle calculation. The original angle step calculation was likely designed to ensure the electrodes spread across 360 degrees. However, there's a simpler way to achieve even spacing. 3. Testing with music. Absolutely. Testing with music is a great way to evaluate the visualization. Music typically has a wider range of frequencies and more complex patterns than a single voice, making it a better tool for assessing how well the electrodes respond to different sounds. 4. User selectable number of electrodes. Yes, allowing the user to select the number of electrodes is a fantastic enhancement. Here's how you can do it. Add input field. Add a number input element, less than input type equals number, greater than, to your HTML, allowing the user to enter the desired number of electrodes. Event listener. Attach an event listener to the input field to detect changes. When the value changes, update the num electrodes variable. Clear the pixel canvas. Recreate the electrodes using the create electrode function. Restart the visualization if it's running. GitHub Copilot prompts. Prompt 1. Modify the update electrodes function to dynamically calculate the number of frequency bins per electrode based on the current FFT size. Prompt 2. Add a numerical input field to the HTML to allow the user to change the number of electrodes. Prompt 3. Create an event listener to update the number of electrodes and redraw the visualization when the input field's value changes. Feel free to ask if you have any more questions or want help refining the implementation of these features.
One. We're having trouble accessing the microphone. What? Right. Yeah, we need to change the JavaScript as well. Just have to trust. Just have to trust the robot. We can get rid of that. The number of lectures is now a variable. One, two. Okay, it's working. It's the default. Yeah, we don't like that angle. We only need it once as somewhere. One. One. It's kind of nice. Hey, one question. Well, there's many questions, but have to start somewhere. Yes, the stuff we tried for the angle. Yeah, we might need an overview on that one. Just turn the microphone off for a second, see if I can activate the high electrodes. Yeah, I can't really do it with my voice. Don't know if it's the microphone or what's up. Well, obviously the frequencies are there. What happens if I turn that off? This should be activating higher frequencies. Yeah, this is activating this too. Yeah, might need to release it a bit. But yeah, okay, this actually works quite well, because now I'm getting more confident. Let's do less electrodes. Yeah, that one is getting activated fine, just fine. 1, 2, 1, 2. Yeah, don't like how we have only 4. Nah, it should be fine. It should be fine. It should be fine. Yeah, so we can see how the filters work. How the filters work. How the filters work. Well, this way nothing should get activated. Should actually not be possible for these sliders to change, opposite directions or whatever. 1, 2, 1, 2. Yeah, this will activate the higher electrodes. To know how should the angle step is calculated correctly. Make sure the filters type low pass and high pass. Make sure the filters go connected to the analyzer. Okay. Yeah, that's right. Update the checkbox changed. Make sure the filters order in the house. Select, yes, it should be selected by the user. Probably not. Probably be too much. No, just will make it unnecessarily complicated. Is set to the correct values. So using Gemini because GPT-4 gave us a timeout. It's probably back now.
Absolutely. Let's address all the points you've raised and refine the code for the cochlear simulator. Here's the improved JavaScript, main, JS, code with explanations and prompts for GitHub Copilot. Key improvements. Dynamic electrode layout. The update electrodes layout function now dynamically adjusts the number and positions of electrodes based on the slider value. Optimized angle calculation. The angle step calculation is simplified to ensure even spacing between electrodes. Sample rate. The audio context. Sample rate is explicitly set to 44,100 Hz, a common audio sample rate, to ensure consistent behavior across browsers. Window resize. The update electrodes layout function is called in the window. Add event listener. Resize. To ensure the electrodes are repositioned if the window is resized. Additional notes. Electrode depth. To visually represent depth of insertion, you could adjust the size or transparency of the electrodes based on their position in the spiral. Copilot prompts. The provided prompts are already quite good. You can continue to use them to guide Copilot in making further refinements.
This is pretty good to be published. Let me know what you think. And I'll see you next time. Bye.